Hi, my name is Galván, and I'm glad to present the next investigation done by Dr. Alfredo Lawise and me called the Gold 22 Silver Sulfur 17 Cluster Doping and Ligand Effect on their structural and vibrational properties. We are part of the Facultad de Ciencias Físico-Matemáticas on the Universidad Autónoma de Nuevo León. Just an introduction, in this work we done a DFT study of bimetallic thiolated gold clusters. We substitute 1 and 2 atoms by silver atoms in the parent gold-22 sulfur-17 cluster. The isomer of minima energy were determined and ligands were varied. When SH, CH3, and pH were considered, a major distortion was obtained with respect to SH ligand. Finally, we calculate the ER profiles showed and it can be correlated with the induced distortion. Okay, let's talk a little bit about the methodology. All our calculations were based on DFT as implemented in the ORCA package. Okay, as we said previously, we work with different isomers. In the figure number 1, we can see the doped isomers with one atom of silver. In A, we have the isomer number 1 with a silver atom in the surface of the nuclei. In B, the isomer number 2 with the silver atom on the edge of the nuclei. And C, the isomer number 3 with the silver atom on the staple of the structure. We can see that the yellow first correspond to the gold atoms, the black ones to the sulfur atoms, the light blue to the hydrogen atoms, and the blue ones to the silver atoms. Well, in the table number 1, we can see the isomers and the relative energy. Okay, as we see, the isomer number 1 had the minor relative energy, so that's the one what we wanna work. As we made with one silver atom, for 2 of them we built 5 different isomers, and the one with minor energy was isomer number 3, that is the C on the figure number 2. And in the table number 2 we can see the relative energy, and for the isomer number 3 the atoms of silver in this isomer was on the surface of the nuclei. Now we're gonna pass the results. In the figures 3, 4, and 5, we can see interatomic distance graphics. On the ordinate axis, we have the bond index, and the abscissas, the bond length in Armstrong. On the figure number 3, in A we have our structure optimized in ORCA, and in B we can see the structure proposed by Zeng and company. For the figure number 4, in A we have our structure optimized in ORCA, on B doped with one silver atom, on C the isomer 1 doped with 2 silver atoms, and D the isomer 3 with 2 silver atoms. On figure 5, for A, B, and C, we have CH3 as a ligand, and D pH. On A we have the optimized version, B doped with 1 silver atom, finally C and D the isomer 3 doped with 2 silver atoms. As we see in all of these interatomic graphs, they keep a good stability. We just can see a little distortions on the gold-gold bond, but it is not clearly at all. If we want a better perspective, we're going to see their corresponding IR spectra. Okay, on the figure 6 and 7, we can see the different IR spectra for each case studied, but we can see change when the ligand is changed. On figure 7, when we use pH as ligand, the absorption peaks increase a lot. Okay, as we see the cluster predicted by Zeng and company have a good stability. It will be interesting to dope the structure with some other type of elements. The conclusion is the ligands tend to make other structure change in their physical chemical properties. Thank you for seeing this video and be interested in our investigation.